Hi to everyone. In this video, I am just going to discuss about quantifiers in discrete mathematics. Actually, quantifiers refers to the quantities of a variable, or else it may be of a predicate such as for all or some. For example, here I am going to take the predicates as here I am having the statement as all men are mortal. This is one statement. And next one I am taking every apple is red. And then I am taking any integer is either positive or negative. So you just see here, I have already mentioned quantifiers refers to the quantities of a variable such as for all or some. Okay. So this all value which will be considered as the universal quantifier, and sum which will be considered as an essential quantifier. For all will be denoted by the symbol this one, or else actually it may be represented like this one, or else it will be represented like this one. This is for the universal quantifier. And for the essential quantifier, it will be represented like this one. Actually, quantifiers are of the two types. One is the universal quantifier and next one is the essential quantifier. If it is of the universal quantifier means for all the values it will return the true. For all the possible things it will return the true. And for the essential quantifiers it will exist in the universe. That's why it is called as an essential quantifier. For all represents the universal quantifier, and for some values it represents the essential quantifier. In this example, I have taken the three statements: all man are mortal, every apple is red, any integer is either positive or negative. So I can rewrite this one as a for all x. Why I am taking here it as this one means all man or mortal. I am just rewriting it as for all x if x is a man. If x is a man, then x is a mortal. So I am rewriting the statement as all man or mortal. This is a statement. I am just rewriting it as for all x. When I can say it as a for all x, if x is a man, then x is a mortal, because here the statement given here is all man. So that's why I am rewriting like this one. And for here, every apple is red. Every apple means it indirectly says all apples are red. So I can rewrite this statement as for all x, if x is an apple, then x is red. And then you just consider the third statement: any integer is either positive or negative. So it means any integer means it can be of any integer. So it means indirectly says all the integers are either a positive or a negative one. So we can rewrite it as for all x, If x is an integer, then x is either positive or negative. So you just see these statements here. We are all having for the all x, Already we have mentioned for all can be represented by means of this notations, right? In order to write it in terms of these symbols, at first what I am just going to do it here is I am just going to consider m of x as x is a man. X is a man. And a of x as here I am taking m of x as x is a man, and h of x as x is a mortal. First I am writing it for the first one. Next for the second thing I am writing here as a of x as x is an apple, and here I can write h of x as here I can write it here as I am naming it as r of x. Okay, so I can write it here as r of x is x is red. And then for the next one I can take n of x as x is an integer. X is an integer, and here I may take p of x as x is either positive or negative. So in such a way I have written it. Okay. So I can substitute these variables here. So if I am substituting here means what's the value that I will get it here? I am just writing it here. So we are just going to substitute these things in this statement. So it means for the first statement I will get it here as for all x. That's why I am representing x within the parenthesis, open parenthesis as close parenthesis, because for all notations I can represent it by means of this symbol, or else I can write it like this one. So here I am writing like this one, and here I am writing m of x. Then because if m of x, then h of x, because m of x refers to x is a man, h of x refers to x is a mortal. That's why I am writing here. And for this one I can write it as for all x, what's the value given here? A of x. So I can write it here as a of x. If a of x, then r of x. And for this one I may make use of this notation, or else I can use this notation. Just for an example I am using this notations. And here if x is an integer, then x is either positive or negative. X is an integer is n of x, and x is either positive or negative is p of x. So I can write it here as n of x. If n of x, then p of x. So this is the representation for the universal quantifier, since it's having for all the values of x. It means for all the values of x, if x is a man, then x is a mortal. It means for all the values of x, if this condition is satisfied, then it will return the true values only. So that's why these statements are the example for the universal quantifier. And next one we are going to discuss about the essential quantifier. Essential quantifier means it represents sum. That means for some values, right? So just for an example, we can actually essential quantifier is represented by the notations. This one which will be called as an essential quantifier, denoted by this symbol. Actually, this is an statement. This is a quantifier which represents that there is at least one x such that, or else some values. So the essential quantifier refers to there is at least one x such that, or else some values. Just for an example, I am saying there exists at least one x such that x is a man and x is clever. So you just say here that exists at least one x such that x is a man and x is a clever. So since they have given the statement as there exists at least one x means among the universe you are just going to consider about the only one thing, at least one. It means a minimum of one, right? So it means if you are just saying this value which will exist in the universe, right? So that's why here you can consider this as an essential quantifier. What they are saying, that exists at least one x such that x is a man and x is a clever. So this is an example for the essential quantifier, and we can rewrite this one. We can rewrite this statement as m of x as x is a man. Okay. And then we can write c of x as x is clever. X is clever. So what we are just going to write it here is, what's the thing they have given here? There exists at least one x such that. So these statements which will be represented by means of the essential quantifier, this one. And here x is a man, here I have taken it as m of x. And x is a clever, I have taken it as c of x. And so here the connective is and. So here I can rewrite this statement as there exists at least one x such that as essential quantifier. And I can write it here as m of x and c of x. I can write it here as m of x and c of x, and you can close this one. So this is the notations which is used to represent the sum values, or else it is used to represent there exists at least one, right? So that's why we have rewritten the statement by using the notations essential quantifier, the m of x and c of x. So this is an example for the essential quantifier. I hope that you have understand these concepts clearly. In case if you are having any doubts, kindly post your queries. Thank you.